Hi. How are you guys doing today? I can't see you at all. It's just a black abyss, but I assume there's many people out there. Yeah, so I'm going to talk about Deno. It's a project I've been working on for the last year with some other people. And yeah, before I talk about it, I have to give a disclaimer because I think there's a lot of people in the room here who use Node and maybe use it professionally. And Deno is a project that is very similar to Node. And I don't want to worry you. Like, Deno is very experimental. It's not ready for production. It's not going to be ready for production anytime soon. So don't worry about it. Keep using Node. Node is managed by a lot of very smart people, and it's very stable. So yeah, it's a good piece of software that you should use. But that said, Deno is a new command line runtime, and it executes JavaScript and Typescript. And it's built on top of V8 and Rust and Tokio. How many people know Tokio? No one. Great. How many people are Rust programmers? One. Okay. Well, you guys should check out Rust. It's very nice. And also Tokio at some point. And also TypeScript, the TypeScript compiler itself. And so, of course, the main question is why would you do this? What's the point? Isn't this disrupting the community? Isn't this bifurcating the module systems? Like, nothing good can come from this. Isn't this a Python 3 situation where we're going to end up with 10 years of difficulty with kind of two different forks of the language? And I think those are good concerns, but I think it's time to reevaluate JavaScript and Node. In particular, JavaScript has changed quite a bit in the last 10 years since I originally sat down to do Node. And yeah, the main important features that have been added are typed arrays, which give you like true access to binary data. That was not around in 2009. And ES modules, right? The module system is now standardized, and we don't need to. I mean, the whole require thing was just invented, right? And not very well. And so we have this nice way of importing modules. And of course, the whole promise is async-await stuff is a really important feature for asynchronous I/O, and makes it really interesting to do in JavaScript. And Node has its problems. It's 10 years old, so it has kind of a lot of legacy APIs that aren't promise aware, I would say, or just are kind of showing their age at this point. And the module system in particular is a pain point. You have this Node modules folder, and all of your local modules get installed there. The module resolution algorithm for kind of how you look up those things is quite complicated. It's like, if you're requiring foo, you start walking up the directory tree towards the root, looking for a node modules path, and then walk into that node modules path and try to resolve the module, plus a lot of other things, right? It like interprets package.json, and it's just a very complicated resolution scheme. And in general, in Node, people are using the npm databases for storing the modules, which is great because it works. But it's not very webby. The web is meant to be a bit more decentralized, right? And of course, there's this whole issue of security, right? So V8, the big piece of software on which makes Node and Deno possible, is a secure sandbox, right? You have the ability to execute code and not have it have the ability to do nefarious things in your system. Unfortunately, in Node, we kind of poked holes everywhere in the system, and you can open up EDC password without a problem, which is a bit unfortunate because we've kind of left didn't use V8 to its full capacity. And yeah, these are not problems that are unique to Node. These are problems that Python and Ruby similarly suffer from. Yeah, and I would just say that in my kind of day-to-day life, I'm programming mostly in compiled languages like C++ and Rust and Go. And the types of problems that I'm after are generally in that realm. And I think some people might argue that kind of the era of dynamic languages is over. Well, it's hard to argue that to a JavaScript conference. You guys are probably still very much on the dynamic language bandwagon. But there's people out there that are arguing that Rust is so good that maybe we can write everything in Rust. Go is so good that we can write everything in Go. That's much more imaginable to me. Rust is super painful, very, very difficult, right? Writing something in C++, very painful, very slow. Writing stuff in Go, very fast, actually quite nice. But all of those don't compare to writing a bit of JavaScript, right? If you know it quite well, then you can move very fast, right? You can hack things together and prototype in a very efficient way. Or if you know Python or Ruby, whatever your dynamic language of choice, these are great tools for moving very quick. And so, yeah, I mean, although I don't generally use dynamic languages for the things that I'm making, I end up writing a lot of dynamic code as kind of tooling around the project. Maybe you're cleaning some data, maybe you're renaming a bunch of files, maybe you have a build system that you need to do some random tasks with. You're not going to do this in Rust. You really want to have a dynamic language for that. So I just think that having a good scripting platform is really important. And I don't think that any of the tools out there today are satisfactory. And I just think it can be better, and it's an important enough problem to try to address. So let me tell you about Deno. So it's a single executable file. It's not a tarball. It doesn't come with a bunch of header files. And I would make the promise that it's always going to be distributed this way. Yeah, we want to. I think the executable on OS X is about 50 megabytes. And yeah, we're going to strive to kind of keep it this nice and compact file that you can easily install in different places. Maybe this is meant to be kind of a Swiss Army knife of tooling, right? I want to break this out in all of the random cases where I need a little bit of dynamic language programming. So, if it's on a CI server and I need to, format some files to check that they're formatted correctly, Deno is easily installable with a single command and whatnot. We ship on Mac, Linux, and Windows. And yeah, this executable is supposed to be all you will ever need to run a Deno program. So it's just kind of, this little thing that you can use. In Deno, you don't require modules. We have ES modules. And when you import things, you use URLs to import them. So this is actually how ES modules work in the browser. Have you tried this? Have you tried to import URLs in a web browser? Like this works. So I think this basically solves the module situation, right? Versioning can be done within a URL. This kind of solves the centralization problem too, because of course the server can be specified in the URL. Yeah, and it's just incredibly simple. There's nothing surprising about what it does. There's no node modules. There's no index.js. Deno knows how to fetch and cache and compile code. And you don't really have to worry about that. It's all kind of stored in a hidden folder somewhere. And yeah, it's, you might be wondering, like, often I'm flying, often I don't have internet access. How's this supposed to work? I don't want my program to always have to connect to the internet in order to execute something. And this can work, right? It caches things in kind of it has a certain behavior to the caching in that it never deletes the cache until you reload it. I'll demonstrate that. And bare imports. Do you know what bare imports are? No one. When you just require foo, that's a bare import. That is like not a URL, kind of what you're used to. There's an emerging standard called import maps that we're going to support in Deno. So you'll be able to import from foo. Yeah, and we're trying to be browser compatible with this. So, there's a lot of places where Deno overlaps with what the web browser does. So, for example, like if you're going to make an HTTP request, we have the fetch method, and we try not to deviate from the standard. For starting a new thread in Deno, you use web workers, the exact web worker API. So where possible, we're trying to use these browser APIs. Yeah, so here's some of the things that are in there, which it's actually not that much. And of course, there's many things that Deno does that browsers don't do, right? So like creating a TCP connection. Those don't have a corresponding browser API. And in that case, we kind of invent our own. So it has Typescript out of the box. It's built in. And we use a feature called V8 snapshots. It's a way of basically preloading your program and looking at the heap and kind of taking a snapshot of that. We can basically load up the TypeScript compiler ahead of time during our compilation process and kind of look at the heap, write it to a file, and then embed that file into our executable. And so when we go to start, when you use Deno to compile some TypeScript code, you don't need to first compile the compiler. It can start up very, very quickly using this feature. So yeah, I like TypeScript. I think it's a great way of organizing mature code. But JavaScript also works, right? It's V8, so we can just dump JavaScript directly into the VM. Yeah, I mean, this is kind of the dream, right? This is the optional typing dream. So you start your project and you're prototyping and you want to move really fast, and so you just open up a editor and you start typing some JavaScript and it goes very quickly. And usually you throw that code away because the project goes nowhere. You do something else. But in the rare off chance that this code actually turns into something that turns into a business or whatever, you want to start making this code more mature. So you start adding types. You want to have more tests. You kind of just generally improve the quality of the code. And I mean, what's great about TypeScript is that it's just JavaScript with types added. So I'm hoping with Deno with TypeScript built in that we can kind of have this very smooth transition without having to install extra things, add something to your build system, whatnot. And I think the final step beyond TypeScript is that you're running your program and you realize like, oh, there's some hot code in here. There's a really hot loop in here. This is actually not appropriate for a dynamic language. How do you move that bit of code out of TypeScript and into something that's faster, Rust in particular? So I mean that last transition is not well fleshed out yet, but to some degree we can do that. So yeah, I mean, this is kind of generally how I would want my workflow to be. So yeah, when JavaScript is used, I would just say that it doesn't pass through the TypeScript compiler. So I mean, you basically get a fairly optimal experience when you're using just raw TypeScript. So the startup time is quite fast and whatnot. And yeah, the Deno runtime is written in TypeScript, and so we can kind of provide a full explanation of all the types in there. Sorry, I feel like I'm breathing into this thing really heavily. Yeah, and the standard modules, which I'll talk about in a second, are in TypeScript too. So you get all the nice experiences with VS Code if you use that. And I put a link to a module that allows you to kind of use VS Code without too much pain points. And I mentioned security before. So the idea is, like when you run this thing, when you run a program without any arguments, it's secure by default. So things run in a sandbox. So by default, programs can't access the disk. They can't access the network. And to allow that access, you have to give these command line flags. So for example, I've put allow read equals temp. This allows you to read from only the temp subtree. Or allow net equals Google, only allowing you to access the Google domain name. So yeah, I mean part of having a productive environment is having a set of standard modules that are high quality and that you can access. And in Node, we kind of have this problem where the standard library is very small, which is kind of a nice design choice, trying to keep things simple. But by pushing everything into the third-party ecosystem, into NPM, you kind of have this proliferation of like very small modules. Nobody knows what's the standard way of doing anything. There's just like many ways of doing everything. And so you end up getting these really crazy dependency trees. And so my hope with kind of defining a larger standard module set is that we can avoid this problem, because if everybody ultimately links back to the standard modules, then kind of this dependency tree that goes off in every direction terminates relatively quickly, because everything kind of would terminate at this in the standard modules. Yeah. Yeah. I mean, these are under development. I put some links here to a couple of the modules. These things are audited in that, like, I review all the code or Bert reviews all the code. This is not just kind of a free-for-all on GitHub. And these things don't have any external dependencies, so you can kind of include these things with some reasonable sanity. And yeah, it's generally organized after Go's standard module system, which I think is really well done and really well thought about. We kind of want to avoid inventing APIs, because that takes a lot of time and effort. And this has been done many times before. And Go's done a very good job at it. So, generally, when somebody's trying to include some new code into Deno standard, I would ask, where's the equivalent bit of code in Go's standard library, and can we take their documentation? Can we copy their interface? Can we copy their tests? This kind of just allows us a bit of like intellectual scaffolding to design the standard library. And yeah, it's versioned with Deno, so you can link to @v06 and know that it will work with Deno 0.6. I'll get into some demos in a second, but I thought I'd just give a bit of an overview. So native bindings, this is kind of a core design. This is actually how Deno started, was thinking about how Node built all the bindings to all the various things that Node does, right? Node has bindings to all sorts of system functionality. And it's kind of like all over the place, right? It's kind of a lot of code, and ultimately, kind of at the event loop layer, like Node doesn't really care about how things are being bound together. It's more caring about notifications and handling data and moving data around. So I think a very nice way to organize such a VM is to make all of the bindings done through message passing. So essentially, you can allocate some uint8 array in JavaScript and send a pointer to that. Send not a copy of it, but a pointer to it into Rust, where you can do some Rust stuff, some system stuff, and kind of get a callback into JavaScript with another uint8 array or with nothing. And generally, you can just kind of serialize any sort of operation that you want to do into this. And so this makes it a really simple, makes it nice kind of at the lower layers of Deno for organizing things. So we don't expose like the V8 API to embedders, to people who are writing bindings, right? If you want to write a binding to, say, file system events, you can't access raw V8 handles. You can't like create a global. That needs to be done in JavaScript code, and then somehow whatever you're trying to do serialized into a buffer and sent over to the Rust side. And oops. So yeah, I mean I think that this is actually very performant in ways, because it can be handled all very uniformly. So native bindings are actually promises. This is kind of a big part of what Deno provides is that it's essentially a way of connecting promises in JavaScript to futures in Rust. And yeah, there are ways to make a synchronous call into Rust, but I mean generally it's always resulting in a promise. So it kind of has this very simple. All of the native bindings are very similarly organized, and I think that makes it easier to maintain. Yeah, and of course, like in Rust, Rust is growing very rapidly and has a lot of asynchronous modules, and so we want to be able to take advantage of those things. So another feature I should mention is that Deno has a Rust crate, and well, I just realized there's only one Rust programmer here, so for that guy, there's this crate. And this is a very particular use case, but if you have this use case, I think this is really interesting. Sometimes you're making a database, and you want to be able to execute a bit of JavaScript, right? You want to implement a MapReduce functionality for your users. How are you going to do that? Are you going to embed V8? Are you going to try to do that yourself? In general, you're probably not going to do that in the right way. Like we've thought very hard about how to design this interface with between V8 and Rust. So your other option is you can like shell out to Node. You could shell out to Deno even, but I mean that's quite heavy lifting. That's something if I was designing a database, I would not want to do. Yeah, so I think that there's kind of this interesting use case of embedding the runtime inside of other programs, something that Node can't do, or at least can't do very easily. Yeah, so well, with that elongated overview, let me just jump into a terminal here while I breathe heavily in this thing. Okay. You can see that. So Deno is a program, and if you just type it with nothing else, you get a REPL like you do with Node, and you can execute some JavaScript there. So yeah, we don't have the global object, we have the window object, and like I showed you before, here's kind of the global things inside of Deno. There's this capital Deno object. This is where all of the fun functionality is held. So looking in there, you see a bunch of stuff like args, PID, exit. Let's just try one of these. Yes? Oh. Okay. I always have problems with microphones. What was I doing? Oh yeah, Deno.exit. Sure, exits the program, right? Deno.metrics is kind of something interesting. Actually, there's a better way to display this. So it returns an object with some random values in here. If you do console table, you can kind of see this in a better way. So it has this like ops dispatched and ops completed. I was mentioning this binding API earlier, where promises are kind of turned into futures and vice versa. So these things are called ops, and we can kind of inspect these things relatively easily, and we kind of have these kind of centralized ways of tracking this, right? So if you see that there's apparently two ops being done in between these two to do this console table. I think one of them is to actually get the metrics, and the other is probably to interface with with the read eval print loop. Yeah, so oops. If we do Deno help, we have all these subcommands here, which are like eval and fetch and format and info. I just wanted to show you some of these just to give you an idea of what this looks like. So, well, let me show you Deno types. So I mentioned that Deno uses TypeScript and that the whole runtime is built in TypeScript. And so kind of an artifact of that is that we can give you a TypeScript declaration file that defines the complete runtime, exactly what's in this thing. So when I do this, like, prints out this huge file, right? Which I will now pipe into Vim, and I will set the file type to TypeScript. Yeah, so you see there's this namespace Deno with like deno.pid, no color, exec path, is TTY. So all the functionality is very accurately defined in this file, which is a really nice thing to have, right? One of the benefits of TypeScript. We can't really do this with Node. Oops. So, you know, I mentioned that this is like a kind of a little command line utility that I'm hoping that, you know, just kind of solves all of my dynamic language needs. And so, you know, one of these needs is that you're kind of on the command line. You just want to hack around with some stuff. You have a file. You need to munge it in a certain way. You kind of have to do like line-based processing. So Deno eval just evals stuff, right? So if I do like console log 1, 2, 3, it logs that, right? But what is Deno xeval? Deno xeval is kind of like xargs. Xargs. Does that mean anything to anybody? Okay, yes, thanks. So it executes a script for every line of standard in, right? So let's do this. Let's cat EDC password, right? Which is this big file. And yeah, so the kind of the last bit of the EDC password is the shell that it executes, this user bin false, right? Why don't we try to like grep this? So let's basically do this command. So I'm going to grep the EDC password for false, right? So how would you do that with xeval? So the current line is $. So for example, if I do like if $ includes false, then console log $. Oh, I guess I messed that up. Okay, log. Okay, right. So this is basically, you know, a really long way to write grep. But what's nice about this is that it's JavaScript, of course, so we can do a bit more. So why don't we, you know, these lines are kind of colon delimited, right? There's all these various fields in here. Why don't we try to pull out the first field here? So we'll split on the colon and grab the first field. So if it includes false, then let's do console, let's log the first thing. So console log $ split colon, right? And then like the first element, right? So this is kind of you know, you're a better awk, or maybe not better, a more verbose awk. So you know, I guess I just showed this as an example of kind of tooling that comes with this that I think kind of helps you in your day-to-day stuff, in your day-to-day programming. So yeah, let me show some actual code here. The canonical example for Node was always a HTTP server, and Deno has a HTTP server too. So I'll write this in JavaScript. So the HTTP library is not built into Deno. It's actually in the standard modules. So you have to import serve. There's a function called serve from Deno land, which, by the way, is just a redirection service to GitHub. If GitHub had prettier URLs, I would just, ideally we could just write github.com, ry http server.ts. This would be great. Unfortunately, this doesn't work yet. So Deno land standard http server ts is where the server's at. And yeah, basically you just do serve, and then you can give a port, and that will listen on the local host. Maybe we can console log something. Listening on port 1000. So let's see, we've got webserver.js. So the way that you run this thing actually is you do Deno run and then the program. Okay, so first thing that happens is it says Deno requests network access to port 8000. Do you want to grant this? So this is part of this whole security model, right? It doesn't allow you to just start serving connections on port 8000. That would not be a secure sandbox. So you can either type always and like actually grant it access interactively, or you can kind of grant allow net kind of like this, right? So of course we haven't done anything yet. So yeah, to actually accept connections, we do this for await loop. For await let request of, maybe I'll just put this guy over here. Delete that. So console log got a request. Doesn't seem good to you? So when I run that, it says, syntax error, unexpected reserve word. Any suggestions? We don't support top-level await, unfortunately. Or I should say V8 doesn't support top-level await. What we need to do is wrap this thing in a little, this is a bit of boilerplate. So basically I'm just going to put this guy in this async, right? So, I have this bit of boilerplate that I have to write to actually do async things. Let's try this again. Okay. Of course, listening on port 8000 is printed before I actually do it. So if I curl localhost port 8000, I get a request, but I don't get a response because, of course, I haven't sent a response yet. If I cancel that and send another one, I get another request. Okay. So let's send a response. Respond, and yeah, you can give a body, and this body is some uint8 array, which I need to define. Const body equals, and well, how do you? What I want to do is just send like the string hello, but Deno doesn't do string encoding for you. You have to. It doesn't do text encoding for you. You have to do this yourself. So this is meant to be a lower level library that you would have a framework on top of, right? So this is essentially just providing the HTTP parsing. But the way that you can turn this guy into a uint8 array, into an array buffer, is to use the text encoder, right? also a browser API. So yeah, we're generating a U. Is that a UNA? I think so. All right, so if we restart it and we curl it, we get hello back, right? So yeah, so this is an example of using the standard library and using URL imports. Let's examine this a little bit further. So if I do Deno info web server, this is going to print out a bunch of information. This tells me something about what this script is doing. So of course, it's local location and what it is. It's TypeScript, but it also gives me this dependency tree of things that it depends on. HTTP server depends on buffio.ts, which depends on util.ts, right? This is a very nice utility to have. This is not even something that is limited to Deno scripts, right? I mean, if you're using ES modules in web browsers, you can of course use Deno info with that as well. So I mean, for example, well, let me show you a different program. So you don't have to actually have the program downloaded onto your computer or like in the current directory to run it. You can just supply a URL. So in this way, it's kind of like a little web browser. So what I'm going to do is run a program that serves up the local file system, right? So we'll serve up this local directory as a HTTP server, and it's called file server.ts. So I'm going to run this, and yeah, of course, this thing is going to give me some permission prompts. Oh, yeah. So it wants to listen on like, okay, I guess I can allow that. If I open up Chrome here and go to this URL, it's going to spin for a while, and that's because I got another thing. Oh, it wants to have read access. Okay, so this is getting kind of annoying, but now that I've granted that, okay, now it's serving up the local host, right? Yeah, well, I should mention that if you kind of know the code that you're working with, you can always opt out of all of these permissions with this -a thing, right? And then you don't have any problems with the permission prompts. Anyway, I brought up this program because, well, for one thing, to show you that you can kind of just run URLs like this. So this kind of makes a very convenient way to distribute a command line utility. If somebody has Deno installed and you have your program on a website, there's nothing more that needs to be installed, right? You should be able to kind of easily give people access to command line utilities in this way. Anyway, let's look at this info a little bit. So yeah, this program is TypeScript, right? And it has this compiled component and a source map component, and of course this big depth tree too. Just kind of wanted to show you this cache folder. So this. Well, let's just look at this file. This is what this URL has been compiled to. So this is cached locally on my computer. This is the JavaScript that actually gets run, right? Let's go into this cache folder and just have a peek at what's happening here. So let me cd into that. So this is basically where Deno is storing all of its stuff. If I do tree, maybe, let's see if that, oh, I don't have tree installed, damn. Find, less, okay. So in this gen directory, we have all of these very weird-looking files. These checksum files. These are all the compiled Typescript files and their corresponding source maps. And there's quite a lot of them. In this deps folder, find deps less. This is where it's caching all of the URLs that it downloaded, all the HTTP URLs, right? You can even see that it's cached the headers of the requests that it made to get, say, this buff.io thing. Yeah. So what else do I want to show you? Showed you that. Oh yeah, let me show you this new sandboxing feature. So we actually just landed this a few days ago. So what I'm going to do is run that file server again and just kind of demonstrate that we can restrict read access to only a certain subtree of the file system. So I'll try to restrict the reading to /temp, right? So what I'll do is cd into / because this file server serves the current directory. And I'm going to go in here and go back to my run command, right? And instead of giving a -a here, let's do allow net and then allow read /temp, right? So we're only allowing it to read this subtree. So again, it's serving this at 4,500. So let me load that. And it's spinning. I made a mistake here because it's going to prompt. We want to opt out of these prompts, right? We only want to serve this directory. So there's another flag, no prompt, that will just, whenever it doesn't have access, it will just deny it immediately. So, all right, so now we're running. And when I try to load /, it can't do it, right? This should serve up the root directory. But if I go to /temp, then it can actually read from /temp. I mean, just to prove to you that these are the same things, right? So that's what's in /temp. Yes, sorry. It's like, is that actually the same? But if we try to go to /etc password, you can't do that, right? It's going to deny it. So we kind of have this more fine-grained permission system, and I think that the permission system is evolving, and hopefully we'll get better over time. Yeah. So let's see here. Yeah. So oops. Yeah, so this is under development. It's kind of an ambitious project, and there's kind of a lot of things to figure out. And we're trying to be quite careful about it. But I think by the end of the summer or so, we'll have a 1.0 version, hopefully. One of the main things that's missing is debuggability. You can't connect Chrome Inspector to it yet. We'll fix that. We don't really have very good documentation. We'll get a doc website going, which I think will be very compelling, actually. We have some performance issues. We can't do SSL, TLS yet. That needs to be fixed. I mentioned import maps for these bare URLs. I think that'll be very nice. We'll have that done soon. And some more of these kind of utility commands, like Deno test and Deno lint. I guess I didn't mention, and since I have a minute left, let's say I want to format this file, right? So let's say I'm a really bad programmer and I've put a bunch of weird spaces in here. Right, that's the file that I was editing before. We have this Deno format, right, which just runs prettier on it. I think the idea with all of this is just kind of have the whole development experience in much the same way that Go provides. So we'll also have a Deno test command and a Deno lint command. And someday I would really love to do WebGL, but we kind of have to figure out some of these other issues first. And yeah, I should say that this is an open collaboration, and there's many people who work on it, and I would invite you to check it out if you're interested. I mean, we kind of have everything from very hard Rust internal problems, to working with V8 to the standard library is written completely in TypeScript. So, I think no matter your skill level, well, as long as it's somewhat there, it would be appropriate to kind of contribute to this, if you think that such a thing is a good idea. And yeah, thank you for your attention and inviting me here.
All right, Ryan, thank you. Would you like to join me for a little conversation?
Sorry?
Would you like to join me for a little conversation?
Sure.
For a few minutes? Well, we have so many questions coming in, but I have a magic question. Vim, huh?
Sorry?
Vim, huh?
Yes.
You're a big fan of Vim?
I wouldn't. No, I wouldn't say that. It's just what I use and what I've always used. But yeah, it's hard to switch when you're old.
Well, come on, you're not that old. Yeah, there are people who are older than you. Just saying. We have many questions coming in, so I'm just going to jump in. There are like 25 or so. So I think you'll be available to the audience later in the discussion zones and all. Alexei is wondering, so does Deno support plugins like Webpack does?
I mean, you can import URLs, and this is the only sort of plugin that we support.
Mm-hmm. Okay.
Yeah.
What about the cache size of Deno modules? Could it be a problem like Node modules?
So, I mean, less things get downloaded, right? When you install something from NPM, it ends up installing like all these different files, READMEs and bundled artifacts that you might not be using. So in this thing, it's really just downloading what it needs to download. So it should be more efficient in that way. Yeah.
Okay. Vladimir is wondering, can a Deno library author unpublish the package?
Sorry?
Can a Deno library author unpublish the package?
Yes. So it's just URLs. So if So I mean, we have this Deno land thing up there where we're trying to make it easy to kind of do this. But my hope would be that somebody else kind of goes and makes a proper package repository for this stuff where they might support the feature of unpublishing. But I mean, ultimately, from Deno's point of view, it's just URLs, and it doesn't try to make anything beyond what the browser does exactly. So hopefully somebody will make something where you can trust that somebody won't unpublish or won't change stuff after the fact.
So it's interesting because if I look at the state of things right now and I compare with how things used to be, I don't know, 10 years ago, 15 years ago, 5 years ago, it seems like the evolution of JavaScript, the evolution of front-end it's moving so fast. It's really hard to keep up. So I'm wondering at this point, of all the technologies and things that are actually out there, like, we have conversations about WebAssembly, we have conversations about Jamstack, have conversations about Rust. What are you most excited about these days when you look at front end? I mean, I know that this is a project you're working on specifically now, but what are you kind of looking forward to for the next, I don't know, few years or so?
Yeah, I mean, I think, you basically mentioned all of them. Like, I think WebAssembly is really great. Is going to be very useful for those certain very hot bits of code that you might need to execute. So that's exciting, and I think Rust plays really well into that equation. Rust, I mentioned, is a really interesting and good language. I would encourage everybody to check that out, although that's a bit beyond front-end development. But with WebAssembly, I think it starts coming closer to that too. Right.
I have a feeling, maybe I'm wrong, I have a feeling that you spent quite a bit of time in JavaScript. Is that correct?
Yeah. I mean, maybe less time than you would think, actually.
Yeah. Okay. But if you look again in the future now of JavaScript specifically, is there something that you're desperately missing in JavaScript that has to be done, that has to be improved?
I mean, top-level await is definitely super annoying. I think there's many little cleanups like this import maps sort of thing that kind of need to be done, and TC39 is kind of full of these sort of issues that are trying to make the language better. I mean, to be honest, I think the syntax is quite crufty, and I think maybe it's time to like reevaluate a kind of new skin on top of JavaScript, but slash TypeScript. But yeah, that's not something I would do. But yeah, I mean, in general, it's a very nice language because it's just so ubiquitous and runs in web browsers. The actual language itself, it's good enough.
Okay, so the future looks bright.
I don't think JavaScript is going anywhere.
Okay, excellent. That's pretty reassuring for all of us, I think. Okay, thank you so much for being with us.
Yeah, thanks.
Well done. Thank you, sir.